Dear all, this is an introductory class of what do you mean by a signal. Actually, a signal is something that carries information, some sort of information. For example, you are watching TV, you are watching movies. A movie is actually a signal that is conveying you some sort of information. For example, it is conveying some story. Okay, and if you are speaking to someone else, you are conveying certain information to other person via speech signal. So human speech is a signal. Another signal is you are hearing FM radios and all. There also you are hearing signals. So signals means it's a natural phenomena. Okay, in nature, signals can be actions done by an organism to alert other organisms, or it may range from sounds or motions made by animals, then the other species, etc. And in human engineering means what? The signals are the information that is signals are the thing that is carrying information, like the output of a sensor, like that it will be there. Then in information theory, we can refer signal as the thing that is carrying information, more information compared to the other signal. Or we can term, you heard about the term noise, right? Actually, noise refers to a signal, but it is an unwanted signal, and any signal can be classified as wanted or unwanted according to the application of that particular signal. Okay, so noise is an unwanted signal. And another thing is, you are chatting with each other through WhatsApp messages or any other messaging tool. That is also a signal. That test, that is also a signal, because it is carrying some information. So signal is a physical quantity that carries some kind of information. Or mathematically, we can define a signal as a physical quantity that varies with time, space, or any other independent variable or variables. So what do you mean by independent variable and dependent variable? So in maths, you studied about, say, the function f of x. So what is the meaning of f of x is that you have a variable x that is varying from its minimum to maximum. Suppose that x is element of the interval, close open interval 0 to 10. So what is the meaning? Here x can take any value between 0 and 10, excluding the extremes, because I am given it in open bracket. Okay, so x is taking values between 0 and 10. If x is varying from 0 to 10, in that particular range, if the variable f is taking value from its minimum to its maximum. Okay, so that is the meaning of the function of the notation f of x. So f of x means f is the variable that is depending on the value of the variable x. So here x is known as the independent variable. Okay, x is known as the independent variable and f is known as the dependent variable. Okay, so for defining the value of f, we require the value of x. That is the meaning. Same way, the signal is actually defined as a physical quantity that varies with time, space, or any other independent variable or variables. Okay, so for example, we can consider speech signal. Okay, so you consider my speech. I am talking to you using the speech signal. So at this moment, what I am talking, that means this moment means at this particular time interval what I am talking. After 10 minutes, what I am talking. So actually the speech signal is dependent on the independent variable, that is time. Okay, so any signal in signal processing, we are considering the independent variable as the time, the factor time, at which moment this particular action is happened. So that is why we are considering this t as a time as the independent variable. The most fundamental independent variable is the time. Okay, so here time, space, or any other independent variables can be taken, and if I am writing the signal as x of t, the meaning is that the signal x is depending upon the independent variable time, which is varying from its minimum value to maximum value. So that is actually a signal. Okay, now as I said, the signal may depends on one or more independent variables. Okay, one or more independent variable. If a signal is depending on only one variable, that means if a particular signal x is depending upon only one independent variable, say x of t, then this particular signal is known as a one-dimensional signal. Okay, if a signal is depending upon only one variable, then that signal is known as a one-dimensional signal. Now, Now if I'm defining a two-dimensional signal, I can define like this. If a signal is depending upon two independent variables, then that signal is known as a two-dimensional signal. For example, if I'm writing the signal as f of x, y, here the signal f is depending upon two independent variables x and y, then this particular signal f of x will be a two-dimensional signal. Okay, so how I can define a three-dimensional signal? If a signal f, if it is depending upon three independent variables x, y and z, then this is an example of a three-dimensional signal. So, depends upon the number of independent variables the signal is depending upon, we can classify the signal as what? One-dimensional, two-dimensional, etc. up to multi-dimensional. Multi-dimensional in the sense that it is depending upon more than one independent variable. So here video signal is an example of multi-dimensional signal. Actually video signal is a 3D signal. Okay, so these are the main classification of signals. Now you can see here which is the most fundamental classification of a signal, that is actually continuous time and discrete time signal. Okay, so here you can see what is a continuous time signal. So continuous time signal in the sense that suppose you have a signal x of t and this x is defined for each and every value of t. So that is the meaning. So continuous time signal means x of t is a signal, x is the dependent variable, t is the independent variable, and this x is defined for each and every value of t. X is defined for each and every value of t or every moment of time. If that is the case, then that signal is known as a continuous time signal. Okay, so a continuous time signal is defined for each and every value of time and is designated as x of t, y of t, like that it can be defined. Okay, now a continuous time signal is also known as an analog signal. Analog signal means it is continuous in time. That means it is defined for each and every value of time. Okay, now if you need to take an example of a continuous time signal, actually every real time signal is a continuous time signal. For example, human speech is a continuous time signal. Why? Because we are talking continuously, right? We are talking continuously from morning till evening. So we can consider human speech as a continuous time signal. Okay. Now another thing is the temperature recorded over a particular interval. That means suppose I am recording the temperature of a particular room from 9 AM to say 10 PM. So I am continuously recording the temperature, means from 9 AM to 10 PM I am getting the temperature value for each and every time value. Okay, so that if that is the case, it is known as a continuous time signal. For example, if I am plotting a continuous time signal, suppose that I am plotting from say T1 to T2. Okay, I am plotting from T1 to T2. So I am getting a continuous amplitude that is varying from where to where, the time T1 to time T2. Okay, so for at each and every moment I can find a value. For example, if I am taking the moment t is equal to t0, I can find the value at this moment as x of t0. Okay, so this is known as continuous time signal. So continuous time signal means any signal that is defined for each and every interval of time. So this is a graphical notation. As I said earlier, at t equal to t0, I can find the value corresponding to x of t as what? X of t is equal to x of t0. So this is an example. Here you are given the signal x of t is equal to e raised to minus t from the interval t equal to 0 to 2. That means I am considering the time interval from 0 to 2, each and every value from 0 to 2. I need to plot the signal x of t equal to e raised to minus t. So we know that if the signal is varying from 0 to 2 means I couldn't take all the values within the range 0 to 2, because if I am taking the decimal up to 4 place, the first value after 0 will be 0.0001. The second value will be 0.0002. Like that I need to go till 2. So that much value I couldn't take. So I am taking certain values in between 0 and 2. First I am taking t is equal to 0. What happens when t equal to 0? Is t equal to 0 means x of t is given as e raised to minus t. So at t equal to 0 I am getting x of t equal to e raised to minus 0, that is equal to 1. At t equal to 5, if I am substituting for t equal to 0.5, I am getting the value as 0.606. Like that, I need to proceed till the last value t equal to 2. Okay, so from t equal to 0, I am getting here. T equal to 0.5, I am getting the value. T equal to 1 also I am getting the value as this. T equal to 1.5, I am getting the value like this. And T equal to 2, I am getting the value like this. And if I am plotting the signal by taking t along x-axis and x of t along y-axis, I need to take first value t equal to 0. So t equal to 0, I have obtained the value as equal to 1. For t equal to 0.5, I have obtained the value as 0.606. At t equal to 1, I am getting the value as what? 0.368. Okay. And at t equal to 1.5, I am getting the value 0.2237. And at t equal to 2, I am getting the value 0.1353. Okay, so if I am continuously plotting, because I have taken certain discrete values of t, but the plot is signal is continuously varying from t equal to 0 to 2. So I need to plot it continuously. So I am getting a continuous curve. So this is the graphical representation of e raised to minus t for t from 0 to 2. So this is how you have to plot the continuous time signal or any time signal, continuous or discrete time signal. So the next type of signal is a discrete time signal. So what do you mean by a discrete time signal? Actually, a discrete time signal means the signal amplitude is continuously varying. Okay, the signal amplitude is continuously varying from one value to other value, but we are taking a discrete interval of time. Okay. So I am repeating, the signal amplitude is continuously varying from its initial value to final value, whatever be the values, initial value to final value. But I am taking the amplitude at regular intervals of time. For example, in this figure, first of all, I am taking the value at t equal to 0. After t equal to 1 second, that means at t equal to 1, I am again taking the value. So I am getting one value. So here also I am getting one value. At t equal to 2, I am getting another value. At t equal to 3, I am again taking the amplitude. So I am getting the another value. At t equal to 4 also I am taking the value. At t equal to 5 also I am taking the value. So this means what? I am making the time interval discrete, but the amplitude is actually continuous. Okay, so what do you mean by a discrete time signal is that it is continuous in amplitude. Amplitude is continuously varying, but we are monitoring a discrete interval of time. So the signal which is continuous in amplitude and discrete in time are known as discrete time signals. Okay, then usually discrete time signal is denoted as x of n, where n is an integer. Always remember, n is an integer. So this is the basic of signals. What do you mean by a signal? Continuous time signal and discrete time signal. Okay, thank you.